Welcome everyone to our webinar. We're going to give a couple minutes to get started to let people settle in. And in the meantime, if you can use the chat function to share with us where you are dialing in from, that would be great.
Ooh, look at that. We're hot on the polls already. If you didn't see it, we'd love to know what role you play at your company. So not only good morning from wherever you are, but also what role you play at your company. While we're waiting for people to join, and while people are giving some good mornings, Alexa's gonna love this. Let's talk about the weather. So over here in Denver today is a little cold front right over here that moved through, and it's nice and chilly today. Going to be low 80s as the high. Who else do we have? John, where are you at?
I'm in the Bay Area.
Bay Area. So okay, over here, some rain coming in today. Looks like for
Yeah,
you.
we're
Yeah,
expecting showers
exactly.
apparently.
Excellent. All right, great. Little tiny cold front moving off the coast into the Bay Area. Folsom. I don't even know where Folsom is. It's like here, here, ish,
Little,
ish.
yeah,
Yeah.
that's about a
Yeah,
bit up.
some more rain there.
Yeah.
Lex is hanging out here today,
Mhm.
so she gets the nice, cool, but also sunny weather. Where everybody else? Where are you from? Well, we're waiting. We're gonna get to the API security stuff here in a second, but the weather report is just as important. Okay, it's less. It's way less important. We're just killing time here. Caitlin in Denver. All right, great. Got a couple AppSec. Got an AppSec. Got a DevOps. Got an other.
Give people a few more minutes, and then I think we'll just start at the 5 after.
Oh, I see what's happening here. People don't want to let me know where they're from because I don't have the right map. I might not have the entire world map. I can only do North American weather because that's all I have access to the maps for. So apologize if I can't cover your weather today. All right, no more weather. Give it about 2 more minutes, wait for people to join here, and then we'll get rolling.
And how's our poll looking?
I think we have 3 people who have answered. So
Okay.
if you are just new and joining, please let us know where you're joining from in the chat. And then we've got a poll up. Just curious about your role in your organization. More other. 1 more minute.
It did not have solutions architects.
You're right. I don't. There is no solutions architect. But we know that, John. We know what you're up to. Got some DevOps people joining us. Shafi, I think that is. If I butchered that, I apologize. I'm doing the best I can over here.
All right. What do we say? You ready?
Let's do it.
All right. Okay, well, thanks everyone for joining our webinar, The API Security Problem, What You Need to Know with StackHawk and AWS. Before we get started, for any questions, please use the chat or the Q&A function within the Zoom toolbar. This webinar will be recorded and available to you all in the next day or so, so check your emails. And with that, I'd like to introduce our presenters, John Tordeve, Senior Solutions Architect at AWS, and Scott Gerlach, CISO and co-founder at StackHawk. And Scott, I will let you take it away.
Yeah, awesome. Thanks, Alexa. I super appreciate it. Welcome, everybody. If you're watching this recorded, remember the weather's not accurate. That was accurate when we did it live. It's not accurate now. But thanks you for joining us if you're here live. John, you want to do a little intro of yourself?
Sure. Hello, everyone. My name is John Turdiev. I am a solutions architect at AWS. I work primarily with cybersecurity startups. Been with the company for about 2 years. Before that, I have about 20 years of experience in mostly IoT and cloud and security.
Awesome. And as Alexa mentioned, I'm Scott Gerlach, Chief Security Officer, co-founder here at StackHawk. My background is as a security operator. So I was the CISO at SendGrid for about 3 years, and I did a ton of different security jobs at GoDaddy for almost 10 years. I'm also a husband, a dad, a golfer, a home Kubernetes admin, which I also call husband job security. Everything will fall over if the Kubernetes cluster dies. Good for me. If you want to connect with either of us after this, there's my Twitter and my LinkedIn, and John's got his LinkedIn there as well. What are we going to talk about today? So a little bit of what we're going to talk about, just kind of API security problem as a whole. Some of the AWS, John's going to cover some of the AWS services that are helping customers and organizations create APIs and value and get them into customers' hands quickly. Talk about the shared security responsibility model, how API and application security testing is happening, and what StackHawk does, and how StackHawk can help this whole thing. And then we'll do a little recap and some Q&A. As Alexa said, if you have questions, please drop them into either the Q&A or into the chat. We'd love to keep this interactive, chat with you back and forth throughout the webinar, answer questions live. If we say something, you're confused, you don't get something, you disagree with something, put it in the chat. All right, let's get started. So let's talk about the API security problem a little bit. As you may know, almost every company is now a software company. And speed of delivery of the value is the key to winning in a ton of those organizations. So when we talk about every company as a software company, we mean the obvious stuff, obviously, like a software company or a SaaS company or a company that delivers a mobile application. Those are all software companies. But you've got other industries and verticals that are now joining the ranks of the software company because it helps deliver value. So, some of the things that I can think of off the top of the deck. Oh my gosh, look at this. I'm totally not doing that. Sorry about that, everybody. Totally my bad. Here we go. Every company is a software company. That's hilarious. That's a huge fail on my part. So where was I? I was talking about people who have become software companies, and we're talking about things like restaurant chains who are managing all of their software in supply chain to order food on a mobile app, or order food, or manage how that raw food is getting to each different restaurant itself. Drink manufacturers managing software to create AI and machine-driven store experiences. So again, how to in-store order custom drinks, how to order, new kinds of drinks, whatever that might be. And then if you think about it, even banks, like if you're doing banking and your bank doesn't have an online experience or an app, are you considering them as a bank? You might be like, I'm going to put all my silver there and no one will get it. But generally, most people like online banking, mobile apps, all that good stuff to be able to have the convenience and the value of doing that banking via software. So because of that, what's happening out in the industry is APIs are becoming super, super prevalent. And they're becoming one of the largest attack vectors, and they're growing exponentially. Because of all of this software, this digitalization of company experiences, we're building APIs, we're delivering APIs, and it's becoming a huge piece of all what's happening on the internet. So some of the things that are happening out here today, if you, some of the reports that we've seen out there, 70% of all internet traffic is API driven. So if you think about that, that's a crazy number. And it doesn't seem real, but if you think about, stuff you interact with every day, if you think about scrolling on Instagram, scrolling your Instagram, scrolling your YouTube, scrolling Facebook feeds, all of that is API driven. Watching YouTube feeds, all API driven. Interacting with AWS, all API driven. So because APIs have become such a standard language in how computers talk back and forth to each other, it's also become a very standard language in how humans interact with those computers and ultimately with APIs. Now, the problem, and this is not necessarily a problem, is devs with their LLM AIs are instantly becoming 200% more efficient at writing code and delivering value. Now, not all of the devs, but most of the devs who have used an LLM or used a coding assistant have become 2x more efficient at completing a task. Now, that means a lot more software is being written, and it means a lot more software is being delivered quickly. And 64% of companies use AI generated code assistants, and that's going to grow to 85% in 12 months. Now, what that means is there's just a ton of APIs, just API explosion happening. And security teams are struggling because they already don't know what APIs are in production. Securing them is a really insurmountable problem with existing solutions, and it's only getting worse exponentially faster. Does that make sense to you, John? He
Yeah,
said yes. He shook his
definitely.
head yes. What that looks like, if we were to visualize that, it looks a little something like this. So as our release frequency is increasing and new vulnerabilities are introduced, correlated to the amount of those release frequencies, whether that's person introduced vulnerabilities, framework introduced vulnerabilities, or AI introduced vulnerabilities, all of these new APIs continue to be unknown to security teams, and they're getting introduced at this unprecedented rate. So as our release frequency goes up, and you could argue that it was already really quick, not kind of zero. So if that chart was like, once a week, the release frequency is starting at once a week and going up from there. And everyone's familiarity with the code as we're using these AI generated language models is going down. So security teams are generally not aware of familiar with code bases, and even development teams are becoming less familiar with code bases as AI is helping them complete their tasks and their job. So what you got there is increased releases, increased vulnerabilities, less familiarity with code, and all of that leads to that risk piece over on the right-hand side of our slide here. So John, can you help us understand what AWS is doing to help customers, organizations, businesses deliver this value? Ultimately, the backwards end of this is contributing to this API security problem that security teams are having, but also enabling businesses to go really fast.
Yeah, sure. Thank you, Scott. So what's enabling the increase in speed of development? From our AWS perspective, we have several services and technologies specifically focusing on helping developers build and deploy API rapidly, right? Like, for example, services such as AWS Lambda for serverless computing, Amazon API Gateway for creating and managing APIs, and also AWS Fargate, for example, for running containers without managing infrastructure, have made it easier to build and scale APIs, right? And in addition to that, we have many other compute services, as you can see. such as EC2, container services such as ECS, EKS, serverless compute, and many others. And maybe lesser known, but we also have on-premises and edge computing services such as AWS Outposts, where it's possible to deploy your APIs. And last but not least, we also have several flavors of load balancers that can act as entry points for APIs as well, right? So helping you to quickly and rapidly, deploy your workloads in the cloud. And AWS provides a lot of flexible services designed to enable companies to more rapidly and reliably build and deliver products in AWS, following DevOps practices. These services simplify provisioning and managing infrastructure, deploying application code, automating your release processes, and monitoring application and your infrastructure while they are running. Earlier, Scott mentioned the impact of Gen AI and all those fancy LLMs helping in developer productivity. We also have AI-powered tools to help you author code rapidly. For example, Amazon Q Developer provides inline code suggestions, even vulnerability scanning, and chat functionality right from IDE. We support many IDEs such as JetBrains, IntelliJ IDEA, Visual Studio, VS Code, and so on. And while you maintain this high speed of development, it's really, really important that you maintain a high security bar. And one way to achieve this is by integrating security into DevOps. And this is usually referred to as DevSecOps, right? With this, you can deliver secure and compliant application changes rapidly while running operations consistently with automation. And you can build this entire pipeline. And in addition to that, Scott will mention that in a later section, we also have features to allow you to integrate security testing services. For example, static application security testing, dynamic application security testing, and so on. Yeah. And from a security perspective, we can also look at some of the benefits, as you can see on the screen. When security is integrated into the software delivery lifecycle, teams can remediate critical vulnerabilities up to 45% faster. This is according to Puppet's 2019 State of DevOps report. And the same report also mentions that the high performance in the market are up more than 106 times faster lead time for commit to deploy, and are 2.5 times more likely to exceed profitability, market share, and productivity goals. There are also cost-saving benefits in the examples of AWS. When we adopted DevOps practices, we were able to increase speed of software deployment to an average of 11 seconds. And this increase in deployment frequency can also lead to cost saving because of development operation teams can address the issues faster, and they can reduce downtime and release features much quicker, right? And this also helps to save on the server cost because the infrastructure management also gets better. And last but not least, there's also, believe it or not, is the employee retention benefits in the organization. According to the report, organizations that adopt DevOps practices are up to 2 times more likely to recommend their organization as a great place to work. So let's take a step back a little and briefly discuss how AWS thinks about security in general. At AWS, we believe that security is the top priority, right? With years of experience working with thousands and thousands of customers, AWS has built the infrastructure, the regions, the facilities, right, the networking infrastructure, and so on, to meet the requirements of the most security-sensitive organizations like governments, banks, healthcare institutions, and so on. And the good thing is every customer gets the benefit from all of this. Another thing that we see is that security doesn't start with buying the most expensive tools, but rather it's a strategy that should start from a strong culture of security across the organization, right? So at AWS, security is everyone's responsibility, not just security teams. And of course, this doesn't mean that the HR and everyone start debugging and checking for security vulnerabilities in code, but rather they are, educated to make sure that they can act accordingly and report security issues if they come, such as phishing attacks and other social engineering attacks, right? And often people think of security teams traditionally as gatekeepers, saying no to every single deployment, for example. But at AWS, the security teams aim to be enablers who set up guardrails and automation tools to allow developers and other teams to be able to innovate quickly while still maintaining a very high security posture, right? And finally, AWS sees security as a journey. So not a destination. So we don't just hire all sorts of security engineers and arm them with the tools and then say, okay, job done. But we work on security process iteratively and work on gradual improvement on a daily basis, right? One really, really important thing to understand when building on AWS is the shared responsibility model. What this means is that there are two types of responsibility. So first, AWS is responsible for security of the cloud, which means that this means protecting the infrastructure that runs all of the services offered in the AWS cloud, right? This includes hardware, software, networking facilities, basically everything that allows us to run the AWS cloud services. And from the customer perspective, they are responsible for security in the cloud. And the customer's responsibility will be determined by the types of services they are using, right? This determines the amount of configuration work that's required as part of their security responsibilities. As an example, the EC2 service that customers love and use on a daily basis as an infrastructure as a service offering has much more responsibilities for the customer to configure and secure than, say, managed services such as S3, right? Together with our partners such as StackHawk, we provide services, tools, best practices guidance, and other help to customers secure their workloads, applications, and data. So this helps to address the customer responsibility aspect of the shared responsibility model. And
Yeah, so John, real quick,
Mhm.
I think everyone is probably aware of some kind of an incident involving some kind of data stored in an S3 bucket somewhere. Like along the line, there's been something that's been reported about an S3 bucket. Can you help everybody understand how that, like, what happens there? So how the S3 bucket starts, what happens to enable that kind of an incident, and some of the tooling and information that's out there to help people prevent that from happening.
Sure, sure. Yeah. So S3 is built, as I mentioned earlier, as any other services that we have to meet many types of industry regulations and standards. And this is actually audited by third-party organizations. And you can have access to the certificates and the reports from AWS Artifact, which is a service that allows you to access these, right? So this is AWS's responsibility. So the service is built to be secure and compliant across the globe, right? Um, Most of the breaches and issues happen because of misconfiguration, allowing maybe wide access, or even worse, making the S3 buckets public, right? So this is the customer's responsibility because every situation demands different type of configuration. So AWS cannot configure it for them, right? So the customer has to make sure that the minimum access privileges are allowed. And more importantly, we have tools that can actually warn customers, notify of such potential breaches. We have tools like Security Hub, Guard Duty. We also have security frameworks in Security Hub. For example, you can enable and it will warn you and uh, prompt you to pay attention to such potential compromises. Yeah.
Yeah, awesome. So the general gist of this is AWS is providing secure and secure by default services.
Yep.
It's the customer's responsibility to understand how those services work and continue to check on them over time. Like make sure that they stay in a secure posture where they're supposed to be. And there are tools out there, AWS and partner tools, that can help you continue to make sure that things are secure. You understand where data is located, where APIs might be deployed, where S3 buckets are, and what the security posture of those things are.
Correct. Yeah.
Awesome.
All right. So continuing on, I'm gonna summarize everything here. We've talked about how AWS approaches security in general, and we also discussed shared responsibility model, right? And many of these concepts are described in the security pillar of the AWS well-architected framework. So for us, this framework acts as a guide to help build secure, high-performing, resilient, and efficient infrastructure for a variety of workloads, right? I would encourage audience to consult with this documentation as well. It provides a way for us to consistently measure workloads against best practices and more importantly, identify areas for improvement, right? For example, vulnerabilities or some weaknesses in our design. Um, so application security is one of the very important areas outlined in this framework. And application security describes, in our understanding, the overall process of how you design, build, and test and deploy your security properties of the workloads that you develop, right? We've already discussed many integrating security benefits to the software development lifecycle and also the benefits that it brings, right? But just to summarize real quickly, effective application security program or AppSec program helps you increase the speed of development and launching features while still maintaining a very high security bar and ideally even increasing it over time, right? And addressing issues early on costs much, much less. And the other benefit is that you can use all the data that you gather through security reviews at each step of your development to prioritize important actions and automation or standards across the whole organization. I'll pass it on to Scott to continue our discussion of how we integrate and provide some solutions to help you secure your workloads.
Yeah, awesome. Thanks, John. So what John was talking about was DevOps process or DevSecOps process and places and tools that you can use to double check code. Make sure what you're publishing in your application security program is secure before it gets out onto AWS infrastructure and becomes publicly available. So a couple of things that we're talking about today or places that you could integrate some of these things are in kind of that code build while you're doing build and test, code build to use or run StackHawk, do testing of APIs, applications before you publish them, before you release them. And then also you could, if you wanted to, continue to test those applications and APIs once they're in the deploy or they have been deployed using that AWS code pipeline infrastructure. So let's talk a little bit about how AppSec testing happens today. Wow, words are just weird right there. How AppSec testing happens today. And usually what happens is we're in either this blocking or reactive mode. And I like to say reactive mode is like putting out fires constantly and never getting that sweet firefighter downtime in which they do like all kinds of fun stuff. Instead, our security teams are just constantly putting out fires, constantly reacting, and it's really hard to get ahead and help be proactive for our organization to deliver that code. So, as we're talking about this, as the evolution of application security and DevOps integration happened, what happened was a lot of security teams, and this still happens today, security teams take on this role of like, we're going to do the final check. We want to check this code or this application or this API before we deploy it and make sure that it's safe. And somewhere along the road, someone from the business will go, knock that off. We're trying to get all of this value out to customers as quick as possible. And security teams are just kind of understaffed, under-tooled, under-resourced to be able to keep up with the velocity of the engineering team. So John, I don't know if you know this ratio, but the kind of generally accepted ratio out there of how many developers there are versus how many security people is 100 to 1.
Wow.
You know that ratio? 100 to 1, 100 developers, for every one security or application security person, there's simply no way that one security person is going to be able to service manually 100 developers as they're trying to get code out into production.
Yeah.
So that is definitely a thing that happens and ends. The security is blocking releases to production really quickly, especially when you don't have great automation and democratization of this security testing, security information. That turns them into this playing catch up mode. So, okay, deploy it to production. Hopefully, we find all the bad things before the bad guys do. So what's happening here? Ultimately, testing is happening infrequently and is happening in production, which leads to a lot of bad things. But maybe the worst thing is you've put the security bugs in production. And again, that's not a great idea. And then the list of known knowns is small. We know about some of the main or major assets. So we know about app dot, or we know about API dot, or we know about major value assets that are out in production, but we don't know the entire landscape. Ultimately, those testing resources are limited because the security team is the one that's running the tests or doing the tests or triaging the tests. So it's a really small team that's trying to service hundreds or thousands of developers, and it gets really time consuming and hard to do. And then ultimately, nothing ends up getting fixed, right? We push all this stuff to production. Developer teams have moved on to the next value proposition or whatever they're building, and security teams are testing and finding problems in production. And without running around with what I like to call the hammer of compliance, which you can think of as like a Thor looking hammer thing. Hey, the PCI says we have to fix this thing. Oh, okay, fine. What says we have to fix this thing? Nothing. Then I'm not fixing it. And we have this really hard time getting fixes prioritized because we're not integrated into the life cycle. And ultimately, it's actually super expensive to do it that way. So if we John talked a little bit about the cost of the benefits of doing AppSec and testing and security testing during the development lifecycle a little bit ago. But here is like a more visual chart that I like about how this really looks. So if you're finding and trying to fix security bugs, and specifically, this is your primary motive, like I'm going to find and fix security bugs as they're in production, you're talking about a 35 times cost increase in being able to do that versus, if you get it back there to coding, it costs a little bit more. And if you get it into integration component testing, it costs a little bit more. The exponential increase in cost once you get software out to production is really, really hard to overcome, especially with limited resource.
Yeah.
So
Actually,
go
you're
ahead.
right, Scott. Just to comment on this, I see this and I've seen this in my career many times. Actually, some of the customers or, companies, they deploy and there are vulnerabilities or issues, but they are very afraid to disrupt the production workloads because customers are impacted, the SLAs are impacted. So not just the cost, but also the time it takes and the effort. I guess it gets exponentially high.
Yeah, exactly. I mean, disrupting production environments is expensive because it causes issues
Mm,
with customer and value flow. But interrupting developer flow and product delivery flow is also expensive because it hits on that time to value potential customer contracts. Like I've got to get this delivered for
yeah.
X customer by, uh, you know, September 19th. That's tomorrow. And now we got to stop everything to go run around and fix something we just found that's super bad. So, John, I've been traveling around the country for the last year-ish, maybe year and a half, asking people, what's the harder problem in AppSec? And I want you to chime in on this. What's the harder problem in application security? Do you think it's finding security bugs, or do you think it's fixing security bugs? And we're asking this in the poll. So if you're an attendee, please fill out the poll. What do you think is harder, finding or fixing? John, what do you think?
Um, it's a tough one, but if you ask me to choose one, I would probably say finding, because if you know the issue and if you can replicate it, from my experience, fixing is gets easier. especially in early on, right? But again, this is my own perspective as a developer. If I know the problem, if I can replicate it, I can fix it. But if I don't know it exists, or finding in this case would be kind of a challenge.
Yeah, that's a really good point. We have one answer. Come on the poll. Like you just click a button. Just come on, help us out here. Answer the thing on the poll. Finding or fixing. I I swear to God, you won't get marketing material about your answer in finding or fixing. Okay,
Mhm.
there we go. Two people have answered and both said finding. So I always thought I was under the assumption that fixing was always the harder problem because I always had a really easy time finding security problems. Always is fairly easy to find security problems all over the place. And it's really hard to get those security problems fixed because of prioritization problems. Um, but what happened was we asked this. I asked this to a ton of people, hundreds and hundreds of security professionals over the last year and a half. And what actually happened was very similar to what John kind of said, and what's maybe showing up a little bit in the poll. The problem is this: they're both hard. They're equally hard. Because finding requires I have to know about assets to find security problems in them, and that is really tough. Asset discovery in security and especially application security is really, really hard because you have to know where your assets are to be able to test them, to be able to have findings, and then also getting them fixed is also very hard. So both of these problems are kind of equal in the application security realm of what's harder. They're kind of the same because asset discovery and because once you do that asset discovery, you have to have someone fix it. And if you find it too late, like we were just talking about, it's really hard to get that fix prioritized. So when we're talking about a strategic approach to kind of scaling your AppSec program, we got to think about a couple of different, we like to say personas, a couple of different roles that go into this kind of application security program. One is obviously the CISO. The CISO is in charge of understanding all of the risk and advocating for and deploying resources appropriate to manage risk for the business. Generally, that's what CISOs are, that's what their role is. It also involves charts and graphs and all kinds of other fun stuff that are less exciting and less verbose, but generally, a CISO needs to be able to know what assets they have and metrics to be able to build an application security program, then have metrics about the application security program to know how it's operating. And one of the big things that they struggle with here is what APIs and applications do we have and how are we testing them? So that's like the overview of an application security program. Then you also have AppSec teams, AppSec doers. These are usually smaller teams, but they're the ones that are usually doing a little bit of discovery. What tooling should we use to find application security problems and other pieces that go into the actual testing? What problems do we have? What should we be fixing? All that good stuff. And so we're starting to layer in some of the StackHawk solutions into how this helps, how StackHawk can help here. And so API discovery is a piece of that. So that's that asset discovery. We can find where these APIs live, who's working on them, what velocity they're being tested or being developed with, and should you be testing them. And then you've got our development teams and our AppSec teams working together to do testing and remediation. That's kind of the meat of the program, like really testing, finding problems, and fixing them before we deploy them. And then that ongoing oversight and visibility into what's happening in the program. So keeping you informed about, what is getting fixed, what's not getting fixed, what does our testing cadence look like? Are we testing at the appropriate cadence, weekly, daily, on PRs, all that good stuff. And ultimately, that's how we scale that out to become a secure by design kind of a development product delivery organization. So this is all part of kind of the StackHawk solution that sits on top of an AWS. So using code build to automate some of that testing, feedback information, Um, and then giving some of that oversight into what's happening. So dive a little bit more into how StackHawk can help in this whole asset discovery, specifically API discovery problem. What is StackHawk? StackHawk is the only proactive API security solution out there. John can back me up on that. He agrees with this 100%. I don't know if that's true or not. I'm just putting him in a tough place. But when we say that, we mean we can help you discover your API attack surface, test those APIs for vulnerabilities prior to deploying to production, empower developers to fix those API vulnerabilities while they're building code. So back to our chart, we're reducing that time to fix, that cost to fix, significantly down from the 30x to the 5x. I don't know why that's the 5x is that's where you find it. There's no zero. That's weird. Oh, don't build it. That's zero. Costs you $0 to fix security vulnerabilities if you don't build something. So that's a little tough. And then give security teams oversight into development of new APIs and governance over the testing program. That's what a proactive API security solution looks like. It is find APIs before they're deployed, test APIs before they're deployed, fix APIs before they're deployed, and get oversight and insight into what's happening in that program while it's happening. John, does that make sense to you?
Yeah.
Makes sense to him. Cool. Let's look at that as a hierarchy of needs, if you will. So if we think about the hierarchy of needs here, you've got kind of discovery. What assets do I have? And then testing, the ability to test REST APIs, gRPC, GraphQL, and SOAP APIs. I know there's other APIs out there, but generally these are the big four in API land, making sure that they're continually tested. And then StackHawk Oversights gives you confidence that that security program is achieving the goals of testing. And that's where you achieve that true scale. And what I like to call, I feel confident about my API security program, AKA Mai Tai time. Instead of running around with your hair on fire trying to put out disasters here and there, instead enjoying a nice Mai Tai because that program is going so nicely. John, you like Mai Tais?
Is it a drink? I don't
Yeah.
know what it is, to
You
be
don't know
honest.
what a Mai Tai is? Get this
No.
man a Mai Tai. All right.
Yeah.
Let's talk about API discovery and why I think it's super cool and what's different about it. So API discovery from StackHawk is really about using the source of truth, source code, to find APIs and applications that you should be testing. So the really cool thing about that is not only can we find our favorite friends out there, zombie APIs and shadow APIs, APIs that people deployed on an EC2 instance they didn't tell anybody about, John. But also those zombie APIs that are out there making money for the company, but no one's working on them anymore. No one's working on active development. So we can find all that stuff by looking through the source code. We can find those repositories that don't have activity in them. We can find those brand new repositories that just instantly got an API framework and go, hey, you should be getting this under test. But using source code as the source of truth is a really awesome way to get a ton of insight into your asset inventory that you're deploying. So if you're deploying APIs, you're building APIs, deploying APIs, it's in source code. Rarely do you have a rogue developer out there going, you know what, I'm not going to use a source code repository that everyone else is using. I'm going to use some weird thing off the shelf because I don't like Git. Most of the time, your entire development team is like, yeah, this is our source code repository and this is what we use. And everyone's like, cool. And then they start off a new project because they're going to build a new API and they create a new repository. That's indicator number one. And then they add a framework and commit code to it. That's indicator number two. That's right about the time you should be going, hey, I didn't know about this. What kind of data does it handle? Who's working on it? Should we get it under test? How can we make sure that we're about to publish the most secure thing possible? So that's what StackHawk API Discovery is all about. And it's super simple. So to be able to do API discovery with StackHawk, it's very simple, 3 steps. Sign up at stackhawk.com.
Quick question, Scott,
Yeah,
if
go
I
ahead.
may. You mentioned the source of truth being the repository. Is that the only source of information for discovery, or are there any other sources that you
Yeah,
leverage?
that's the source of truth for our discovery
Right.
is in the repository. So we're continuing to increase how that works to understand infrastructure as code, more information to get better and better intelligence into prioritization of what you should be testing and when you should be testing it, that kind of stuff. But yes, we think of the source code as the source of truth in this API security problem. Uh, Rarely are you deploying APIs that you don't have source code for. And if you do, you're talking to vendors about that problem anyway.
Right.
So StackHawk API Discovery, 3 simple steps. There's 3 things you got to have to be able to run StackHawk API Discovery. You got to have a StackHawk account. You got to be able to connect your GitHub, Bitbucket, source code repository, whatever that might be, and connect the 2 things together. So those 3 things and about 10 minutes of your time will give you a really good insight into what source code repositories are creating apps and APIs, how many they are, and generally, when customers do that, about 30% of the repositories are creating some kind of an API or application they should be testing. So what that means is if you've got, 1,000 repositories, maybe there's 300 things in there you should be testing. And most customers, before they start down this path, are testing 5 to 10 different assets. So that's a significant gap. And part of that gap is created by what we looked at earlier, which is that AI is contributing to that, DevOps is contributing to that, the ability to create and deliver value very, very quickly. Questions, John? John, you got questions about this? Anybody else have questions? No questions.
No, it's clear.
All right, cool. John says it's clear. So let's talk. Let's talk about some of the what you should be thinking about if you're thinking about API security testing. So obviously, Discover is part of that. So where are my APIs? How are they instrumented? How are they documented? And using other tools instead, other than specifically API specifications to be able to test those, whether that's a Selenium, Cypress, Postman collection, or curl, any other things that you can use to define an API can help you test them. Being able to understand how APIs work. So injecting legitimate looking data or legitimate data to drive API endpoints is really important part of your API security testing program, because without that, you can't get into the API to really exercise it. Being able to write customized test. So being able to say this business logic is very custom to StackHawk or AWS, and here's what that logic looks like, and I need to be able to recreate that. Or maybe some bug bounty program found a problem with logic in our production app. I want to be able to recreate that and turn it into a regression test so we don't introduce it again. Those kinds of things are really important. And then retest, being able to quickly test an API that you've fixed to make sure that it's fixed. That's what best in class API security testing looks like. Here's how a lot of leading teams are using StackHawk, specifically in AWS, but also all over the place in how they wire up StackHawk, right? So developers write code and they're using those AI engines to help write that code. They check in the code, we can test there, compile and build that code, and then start doing our test suite. So unit tests, integration tests, security tests. If the tests pass, we package it up, deploy it out into our production with code build, code pipelines, etc., and then get it out onto our Lambdas or our EC2 instances or our Fargates or handfuls of other services that help us do that. And if those tests fail, we get that information back to the development team so that they can understand what those tests might be, fix those problems, and get that code committed back so that we can get information to production. And the whole point of that is to help accelerating that time to fix, right? So the earlier we can do those integration tests and security tests, the faster and more likely a developer is. John was talking about this earlier. When we said what's harder, finding or fixing, John was like, finding. I can fix anything I know about if I want to. But the hard problem is knowing that it exists to be able to fix it. And that's why unit tests and integration tests are super valuable. You write a piece of function in a code and you do a unit test for it. If it doesn't work, you know you should be fixing that. In security land, it's really hard to know when you're making security. It used to be really hard to know when you're making security, um, having security issues because it's hard to instrument all that stuff. It's not anymore. So now you can know when you're making security mistakes, and then, like John said, have propensity to fix them because you know about them right while you're in that code, right while you're doing your test suites across the thing. So being able to get that information to developers, talk about those problems in their language, in their workflow, is a really, really um, important part of how your API security testing program should work. Does that make sense, John?
Yeah, very cool. I just wish I had this tool back in the day when I was coding.
Well, when you and I can go have a couple Mai Tais, because I got to figure out how to get you introduced to Mai Tais, invent time machines, and we'll go back in time and give this to
It's a date.
you. All right. Um, I want to talk about an important part of what StackHawk does, and that's SAST and DAST together. John was talking about some of the ways that you can test, SAST being one of them, and that's static application testing. DAST is what StackHawk does. API testing is, DAST is how we do it. API testing is what we do. And putting those two together is really, really important, because what can happen there is SAST might say, hey, there's a problem in this line of code, like the written code itself or how the code flows. But it can be a little noisy and go, there's a lot of problems in this code. And so it becomes a little tricky to be able to prioritize what's going on. And that's where DAST is really cool, because DAST is testing from the outside in on that running application. And when it finds a problem, it's very likely that it's exploitable. It's definitely discoverable. And when StackHawk correlates those two things together and says, SAST found this and DAST found this, it's super powerful for developers in how do they prioritize and ultimately fix these problems, because now they know the line of code, they know how to recreate the problem. They can then use those AI, Gen AI bots like Q to fix that piece of code and then retest to make sure that the problem actually went away. So really, really powerful when you combine the two things together. Get Gen AI in there helping you fix some of that code. Uh, I feel like you can ask Q for little widgets. Is that right? Can you ask Q for cool gadgets? I need a sports car with a flamethrower. Not that kind of Q. All right.
Hopefully in the future.
Okay. So hopefully that makes sense. Putting those two pieces of technology together really help paint the whole picture for a dev while they're building in the way that they're building, and really help them fix those things. So John, let's recap. We've got about 7 minutes left in our webinar here. We can answer questions. So we talked a little bit about AWS, and we talked about StackHawk and API Discovery. Both of those companies have free tier, free trial, so that you can check both of these things out. So, John, talk about free tier stuff in AWS for learning and understanding how AWS works.
Yeah, sure. Yeah, when you create an AWS account with your credit card, the default is gives you many of our services. There's a list on the website, 1 year free usage, and actually some of them stay free for the rest. There's a full list there. I would encourage you to go to the website. You can Google it, but yeah, gives you good resource, especially if you're starting from scratch or you want to do experimentation. I think it's a great way.
Yeah, so do I. I learned a ton about AWS just from the free tier. Help me help our engineering team go fast. And then the StackHawk API Discovery, as I mentioned, you got to have three things. One of them is a StackHawk account, which is also free. And then the ability to connect your source code repository to check out API Discovery. That is the link for that is in the chat over there. API development and deployment is going faster. And I put in here, it's a rocket ship. It's probably going faster than rocket ship. Make sure you're not waiting to catch up. So when we're talking about AI, we're talking about APIs. You got to get on the bandwagon of Gen AI, figure out how it works, what it can do, what it's good at, what it can't do, what it's not good at, and how you can use those tools to your advantage as a security professional or a DevOps professional, or even an engineering professional, or in our case, other. Like I said, Gen AI is enabling those teams to go fast. So you got to figure out how to use it to your advantage. And the only way you can do that is by understanding what it's good at and what it's not good at.
Yeah.
API discovery is super important. I always like to say find APIs in code instead of a little bit more ridiculous way of finding them where you know they're deployed. That's not finding, that's monitoring. API discovery in production is, I don't know, that's called monitoring to me. Like if I know where all of my APIs are and I deploy an agent to listen to the API traffic, I didn't discover anything. I knew they were there. So there's other tools out in the market that can do that as well. And they might be good at monitoring. Discovery is not something they're great at. API security testing. Remember, if you're rolling out an API security testing program, you got to have coverage for the APIs that you're writing in your engineering team, depth to test those completely, and then the breadth to cover all of the different APIs. And then lastly, make sure you're making this part of your normal developer workflow, and that's working with the tools that they work in. So whatever IDE they're working in, whatever source code repository they're working in, whatever code pipelines, code build, whatever they're using to compile and deploy code, make sure that your program is working within that. And then turn your security or AppSec team into consultants on what things we should be fixing, not finding the things to fix. John, anything to add?
No, this is great. One thing that I wanted to just highlight was the Gen AI side. You mentioned a really good point about what it's good at, what it's not, that you should be aware of. That's such an important point that I myself use Gen AI on my day-to-day basis, and I realize some of the problems. A great place I would advise is just to skim through the OWASP top 10 for LLM vulnerabilities. There's one that's really important, I would say, that over-reliance. Like if you rely on it too much and then don't trust, I think human in the loop is a must. But yeah, other than that, I agree with all the points.
Yes. There's one thing that you need to know about generative AI, it's temperature. What does temperature mean in generative AI and what does it do? And basically, it is how much hallucinogenics you're feeding the Gen AI before you ask it questions.
That's a great explanation.
Yeah. I'm feeding it 0. Okay, it's just going to give me straight answers. I'm feeding it 5 LSD tabs. It's going to
Right.
go crazy. All right, enough drug talk. Any questions from the audience? Please put them in either the Q&A or the chat. We'd be super happy to answer them. And if we don't have any questions, Alexa's coming back to help us clean up our webinar, clean up the mess that we made here, and let people know what will happen after our webinar.
Thanks, Scott and John. I hope everyone learned a lot and found the slides and the information as valuable as I did. As
Once I started sharing them.
Once you started sharing them, yes. As mentioned, we will send a recording, and then I think I forgot to mention also a copy of the slides. So check your inbox and yeah, sign up for a free trial at StackHawk. Check out AWS if you're not on there. And ping us with any questions. We'd love to help answer any of your questions. And with that, we'll call it a day. Thanks everyone for attending. Thanks again, Scott and John.
Yeah, thanks, John. Thanks, Alexa.
All right.
Right, team.